This is the All Things Technical, and this is Kent N4KRO here with a Commodore Model 403R tape recorder, reel-to-reel tape recorder. Notice the specifications here. The wide range microphone, ultra modern styling, and interesting speed control. That's intriguing. I didn't know they put that on these models. So let's take a look. This is the model 403R. Nice looking box, and comes with the styrofoam and was packed with the paperwork. Came with the manual. And you can see here it's pretty much a standard manual with the specifications. And notice the wow and flutter is less than 2%, which was pretty much standard on these rim drive tape recorders. Notice some of these other specs here. Kind of interesting. No idea what the actual speed of this tape recorder is. Of course, we could calculate that pretty easily with the length of the reel and the amount of time that you have to record. It's probably 3 3/4. And then, of course, we've got the schematic here, which is of not a whole lot of use. It's just a schematic format. It doesn't have the specification, doesn't have any of the component values in there, which is okay, I guess. Most of these are pretty much standard. This is the DC biasing circuit right here. Anyway, got the warranty card. Let's see if it's still under warranty. I don't know. Let's see here. Oh, 90 days, 90-day warranty. Okay, well, it's probably out of warranty if it was the early 60s when this was sold. But it's nice to have the warranty card. And here is the gem. Came with a microphone, and you can see the foam rubber, how it interacts and reacts with the plastic on the wire. It's got the on-off switch, a little stand here. The microphone is so light that it doesn't really stand on anything. It's just too light, but pretty common microphone. Came with a little carrying strap here that straps into these little metal side pieces here. And then, of course, the earphone. Wonder if it's got an earwax on it. We'll check that out as well. So let's get this thing out of here if we can. Come on here. I'm dubbing the audio because I had a lot of room noise on the original audio of this first taping here, so that's why you're not hearing any of the noise of me removing the tape recorder. There's the battery cover, and you can see some of the wiring interacted with the plastic there and caused lines. There it is, a real pretty tape recorder. Nice looking removable lid. Has these little clips on the side, and there's the Commodore emblem. The reels came with it, and the tape, and they're not frozen. Not a whole lot of tape here, but it'll be interesting to see what's on it. Got the old transistor marking there, volume control, and record and playback switch. But I don't see a speed control switch anywhere. Nothing on the sides. It's volume there. Nope. No speed control anywhere. It's got the rewind forward and record, or rewind and forward. And yeah, so I think that was hype. Had to be hype. Well, the speed is controlled by the rim motor on the rim, and let's see if there's anything in the manual that verifies that there is an actual speed control. But see, nothing here. No mention of speed control anywhere. Nothing about a speed control and record and playback. So obviously that was a misnomer. No mention of speed control. Okay, so let's get into it and look it over here. It's a nice looking little tape recorder, all plastic. Then we've got the battery compartment here. We'll pop it open. Things look in pretty good condition actually. It uses a 1 D-sized battery, a single D-sized battery, and a 9-volt battery for the amplifier. Make sure I got a D battery here somewhere. Alright. And 9-volt for the amplifier. So we just pop the D in there. And we'll open this 9-volt battery and hook everything up. The rubber's all hard. Not hearing any volume. Let's see if we have anything on the tape. Definitely have a clunk. No audio. Let's try this tape in another tape recorder just so we don't record over something really valuable. Okay, we just did a video on this one, variable speed. And it's running beautifully.
Come over here. Is this your money?
No, that's my money.
Say it loud. Say, is that my money?
That's my money.
Look at this way. Is that my money?
That's my money.
J.C. Penney pen crest. See if this one does any better. Let's see what's on this tape. Sounds interesting. Probably a dad or a grandfather interrogating his kid, the poor kid. I used to interrogate my kids like that. Nope, nothing on that side. So we'll record on that side. That's what I really wanted to do, was to see if there's anything that I wouldn't accidentally record over. So now we can record on that side of the tape. And we'll see if there's anything forward. It says record at that mark. I assume the volume is higher this direction, but let's try it with the Commodore microphone. Turn it off. Record. Forward. Alrighty, we're recording on the Commodore model 403R, the Commodore transistorized circuitry and remote control tape recorder. The date is April 30th, 2021, and this recorder has not been repaired yet, so we're testing to see if it's actually doing any recording. The magnet is covering the tape, so that record mode is on, and we've got the volume set at the correct spot. So let's see what kind of recording actually occurred on the Commodore 403R. Remember, you can't rewind in record mode. See? It won't let you do it, which is good. So that magnet is not covering the tape or erasing the tape. Kind of noisy, right? Oh. Yeah, no audio. Let's check and make sure that our battery is making a good connection. Yeah, that didn't even look. Because the transport would work. There it goes. That's tighter. See if that actually helped us any. Don't hear any audio. Actually, I am hearing audio. So let's rewind it. Try this again. Alrighty, we're recording on the 403, and turn the volume all the way up. On the 403 Commodore, make sure that the volume is set correctly. The instructions say to set the play record switch to record and move the transport to forward. Turn the volume control about halfway between minimum and maximum. So I don't even know where that is. So let's put it about right there and see if that's actually the middle of the volume. No audio. Okay, so we got some work to do on that circuit. Got some work to do on the spindles. So if you've watched any of my videos, you know the routine. We'll go through, pull the spindles off. May have to turn this one down. Let's see. Yeah, this has got a notch in it. This one doesn't have a notch. It's just real noisy because the rubber is so hard, and when the metal motor contacts that tire, it just makes a lot of noise. One of the things that we can do to alleviate that is to put a piece of heat shrink around the tire, and that'll quiet down that growl. This one isn't too bad. It'll be better if we get rid of that clunk. And of course we got to oil everything because it's probably got quite a bit of wow and flutter. It said that originally it was less than 2%, so we'll see if we can get to that goal. So we'll pull these screws out, we'll pull it apart. I'll go ahead and do that, and then we'll go ahead and get inside, give you an overview. I'm not going to do the overhaul on video. I've done plenty of those, and they make the videos so long. So let's just get things apart here and take a look at it, and then we'll go from there. Okay, we've got the play rim off, play spindle, whatever you call it. And let's take a look, see if we can find that clunk. I believe that's it right there. So you can see the shiny line right there that goes all the way around. That's the only part of the motor that's touching this rubber tire. The only part that's getting touched is that little tiny ridge. So we'll put this on the lathe. This will be very easy, and we'll just take this thing down and get rid of those bumps and notches. And we might even get into some fresh rubber, because this tire up here feels a little better. But you can see the tip of the motor right there, and it just touching the hear that? I believe the motor changing speeds on us. This grease and everything is all gummy. Now, this motor right here, this side of the spindle, is touching the entire surface of that rubber, and it is really rough. I know you can't tell in the video, but I'm running my finger over it and it's just clunky all the way around. So we'll turn both of these down in the machine lathe, and then we'll bring them back and listen to them. Okay, we've got the case open and we're looking at the insides. I'm working on the spindles. I turned the spindles down, and one of them was in such bad condition. The rewind was in such bad condition. I'm printing a rubber tire for it, and I'll show you that in a minute. But I wanted to figure out what was going on with the amplifier, and got a little bit of pop in the speaker, but sounds like we've got a handful of little capacitors here that are probably need to be replaced. We're just going to go ahead and replace them. It doesn't look like it'll be a big deal. It's a tiny little 4 transistor amplifier. You can see them in there. There's 1, 2, 3, 4, I believe. And there's 1, 2, 3, 4, 5 caps. So that should take just a few minutes to replace them. Alrighty, got those caps replaced in about 10 minutes. And it wasn't any big deal. Let's take a look at these on the meter, just for kicks, and to see what kind of results we got here. (10 microfarad, 11 ohms, and it's supposed to be 5 microfarad. Okay, a little fat. Check that one out. This is a 3 microfarad. Uh-oh, might be a bad connection. Let's try that again. Yeah, it's open. Let's try to make sure. These 0 insertion force. Yeah, so it's open. And that's probably the bad one. That was probably the one that was causing us trouble. Nope, another open one. So you can see these Princeton, I think that's what it says. So there's 2 open caps, bypass caps, or not bypass, but interstage capacitors. And that's 47 ohms, microfarad, and that was supposed to be a 30, so that one was good. So the 2 filter caps, let's look at the schematic here. The 2 capacitors that were bad were these 2. So you can clearly see input from either the record head or play head comes up and comes into the first stage, preamp, and then goes through and comes to the second stage, amplifier or driver. So if these two are open, you're not going to get any audio at all, either record or play, because the record circuit also is dependent on coming through this circuit. The microphone comes through, comes back up and over, so those two were the ones that were bad. The two that were okay was the motor cap and there's a feedback loop here off of the push-pull amplifier, and it takes some of the audio off for recording, comes down and goes through and into the record head. So the microphone comes in, is amplified, and then the audio of the amplified microphone circuit comes through, and this is where it picks it up and sends it down to the record head for recording. And that one was okay, and this one was okay. But no playing. These two caps were bad. So I hope that's helpful to somebody. It's pretty basic electronics, but you never know. Somebody might be new to the hobby, might benefit from a little talk about how these circuits are laid out. Let's put all this back together, and let's just do a real quick check here. We should have decent audio now. Here's the tire that's printing, just about done over there. This has been turned on the lathe, brought all the way down to the metal. It was in terrible shape. So I took this rubber all the way down to the metal and then sanded this carefully. So we're going to glue that 3D printed tire onto that spindle in just a minute. Let's put this back together here. Okay. Put the rewind spindle in there. Forward. Okay, and let's pick a tape. I don't remember what this tape is about, but hopefully we've got audio now. Okay, I'll be very surprised if we get a YouTube flag. Oops, pulled the spindle and everything off of the player there. If we don't get a flag on that one, I'll be surprised, although it's way out of, the speed is really too fast. And I don't remember when I recorded that. I'm sure that was recorded on that tape as a test. All right, let's see. Forward. Running really fast because of the larger spindle. We got to find something here that'll play. Or we'll have fun listening to all these different high-speed recordings here. This is a 3D printed reel. How does that look? Okay, so that was a test. All right, now the reason this is not turning is because it's metal, a metal spindle. Remember, we haven't put a tire on that one yet. All right.
This morning cleaned it up and put rubber renew on the tires and oiled the motors. So we'll see if we got a decent playing recorder now. What I say.
Okay, so that's super fast. So let's, but you know, it actually sounded pretty good. Come on here. There we go. And that 3D printed reel is working great. So either there's short in the mic or bad connection, some kind of feedback issue. Let's try another microphone. Let's try this little jewel right here. We'll just start right there. Go back into record, which is record down or up? Record down. Set the volume level all the way up. All right, we're going to try this recording one more time. Let's see if we get any recording this time. All right, real short recording. Play. Okay. May have nothing to do with the microphone, so let's see. Let's try just without a microphone. That was rewind. So we're not recording anything, have no microphone plugged in. What we'll do is eliminate a problem with the microphone circuit. All right, let's rewind just very shortly here. Okay. Okay, so that's the recording with no microphone plugged in. All right, we're going to try one more mic, just in case. Got so many of these mics laying around here, I don't know which ones are good and bad, but I do know the diamond studded crystal is definitely a good mic. So now we're recording on the diamond studded microphone. Hopefully, turn the volume up. Hopefully it was just a microphone problem, but I suspect that we got some kind of a feedback problem here. I know we replaced the capacitor, and but we may have a bad resistor here. It could be a shorted resistor that's creating super high gain or a bias issue on recording. So let's try that now. So we're going to rewind just a few seconds. Now let's see. Okay, so it did record. So interesting. So it recorded, but we got a lot of feedback there. Let's get this popped out here. Let's see what could be the issue here. Okay, I missed one cap. Didn't replace one cap. And don't know if that had anything to do with it, but let's record now. Checking 1, 2, 3 on the Commodore model 403R. 403R. We're recording on the Commodore tape recorder now at almost full volume. Let's see if we get any feedback. Okay, that took care of it, didn't it? So we don't need it very hot, that's for sure. Let's use the regular Commodore microphone now. And let's see if we get... All right, now we're recording on the Commodore microphone to see, and I've got the volume, well, there's full volume. There's full volume. That's about half right there, about half volume. Let's see if if this is any better. Okay, microphone's not working. We're changing the gain on the amplifier. Changing the gain on the amplifier. Where's the volume control? So right there is the pot, and we were moving that up and down, but the mic was not working. So this microphone may be bad. Let's try another one that I'm fairly certain is working. Yeah, this red tip ought to work. I believe this is a good one. Let's see if that one records. Turn the volume up just a little more. Record forward. Okay, now we're trying once again on the red tip microphone to see if we're actually recording. And let's see if we get a decent recording on this one. Man, that amplifier is hot. My gracious, way too hot. All right, let's try recording there. Turn the volume way down. All right, we're going to try this again and see if, man, that amplifier is so hot. Don't know why. Might be that it's not working correctly. It's just so hot. We're picking up all the noise of the tape recorder and everything else here. And but let's see if the recording is any better. But it's not working correctly. It's just so hot. We're picking up all the noise of the tape recorder and everything else here. And but let's see if the recording is any better. Wow, okay. Well, all right, so that was a successful electronics repair, and we replaced all of the caps, including the one that I missed just a moment ago, which was a this one here, 50 ohm, and you can see the bottom of it. Look at the bottom of it. It's got bleeding out the... Let's get back to the transport issue. All right, what are we going to do with this puppy? All right, I've got a tire over here that just finished printing, so I'm going to try to peel that off of the printer, and we'll bring it back over here and let you see what it looks like. Okay, got the tire here printed on the printer. So what we'll do is we'll glue that to the rim, and we'll try it on both play and record and see. I'm concerned about these bumps right here. They're a little slightly bumpy, and I'm afraid that that might cause bumps across the... If I don't press it when I glue it, and I put enough glue on there where the glue is even, then we should be okay. I think I'll make this the side it comes up. It's a lot smoother because it was on the glass, on the 3D printed glass. So let's glue it, and then I think I'll just set it down like that on a hard surface. I've got a marble shelf over here, and we'll put that on the bench, and we'll let it set right on that marble because it's perfectly flat. Okay, this thing weighs about 30 pounds, and I use it for this kind of thing, to depend on a super flat surface. So now the question is, what glue do we use? Because it can't be too thick or it will leave waves, and it can't be too thin or it won't bond. So let me think about this glue situation. Okay, I'm going to try this, and the way I'm going to put it on is with a disposable brush, stiff bristle brush. And I've got to work fast because the glue dries pretty quickly, so I definitely don't want to dilly-dally. So what I'm going to do is put a sheet of paper down and work off of that paper. Just put some down here. There we go. And this dries pretty quickly. It's not like instant dry or anything. So we'll come in and actually, I think what I'll do is this. Don't want any clumps. Okay, gonna have to get rid of that. And we'll just set it on there. Even all the way around. Got to get rid of that clump. Okay, set it down. Squeeze out any clumps. Okay. See, I've got this second tire for the play reel. You remember we had all this stuff here that was interfering with the play. So I'm going to trim this. I'll do some of this glue that seemed to work fine on the other one. And I think what I'm going to do is try, I think I'm going to do this. Use a clamp and press this thing into like that, and we make sure it's really flat. I gotta clean that cap up. Okay, it's a little sloppy with the glue last time, so I'm gonna try to be a little more careful this time. This is really contact cement, and if you know anything about contact cement, you're supposed to glue both sides, and then it comes in contact with itself. But I'm not going to do that, mainly because I can't get it lined up correctly right off the bat, and I'm afraid it'll create problems. Okay, got it centered. Okay. let that sit for about 30 minutes, and then we'll put it on the tape recorder and see if it got a little more stable play. All right. It's been about 45 minutes to an hour. And got the tire on there. Now remember, the motor is going to run somewhere in here. It's not flat across the tire. It's going to run somewhere along this ridge here. So let's see how it does on the tape recorder. Just a little bit of grease. Much better. I put the cover back on. You can't see the motor. Before, the motor would ride up and down. We're not getting that now. We're not getting that real ride up and down on the motor. So I think we've eliminated a real source of wow on the surface. Alright, definitely improved. You can see the tape reel here is out of round. I wonder if that's because I don't have it placed down. I don't know, but it's the... Alright, that may still be a bad recording, so we're going to do another recording here. We'll just jump right in on top of the existing recording. Plug our microphone in here, put it down here near the audio source, which is this iPad, and let's start some of our technology, no copyright music. Okay, and put it on record. Just all the way up. Yep. Okay, set our record. See the tape moving here? That's going to affect the wow and flutter. Okay. Just see if that's any better. Still pretty hot. Let's try another recording that's not quite so hot. Okay. I'd say technificant improvement on Wow and Flutter. It's kind of a little difficult to tell on this techno music, but the techno music tests a wide dynamic range, and the amplifier definitely covering that. It's a little tinny, but what do you expect from a little 3-inch speaker? So I think we've got a successful repair here. Definitely improved the performance with the new tires, 3D printed tires on the rims, and we've got a wobbly rim here, so I think I'll just let this play. Let's just rewind it. We'll see if we can find a little better reel here, a set of tapes that might be a little bit cleaner and less wobbly. Got a lot of background noise. Let's just record. Let's just record the room noise. Okay, so let's demagnetize this tape and try the recording again. Okay, we got to demagnetize the tape. Now all we have is motor noise coming in. All right, let's record again. Wow. I'd say that was success. So you definitely got to deal with, when you're working on these, you got to deal with the warped spindles or tape reels. You've got to work with the dried rubber on the tires. Got to work with oil on the motor. Got to work with good tape, good demagnetized tape. And then, of course, you got to have electronics that are, in the amplifier electronics that are repaired, like we did here with these capacitors. So I think this is a successful repair. If any of you would like to post any comments or questions, we'll keep it interesting. And thanks again for watching.